All right, today we're gonna be working on the Tesla motor. We've got a lot of changes and swaps and things we're gonna do to get the performance we need out of it. Today we're gonna show you some of the upgrades you can do to your Tesla motor. Tesla Swap is a modern version of Speed Shop upgrades. For today's sponsor, we have Foxwell NT604 Elite Wireless 4-System Scanner. There it is. That looks really good, really well made. So this scanner supports all OBD2 protocols. This works for post-1996 US-based cars, 2000 and later European cars, as well as Asian cars. So not only is this an OBD2 scanner, but it is also a battery tester. All right, this is a vehicle I really don't know much about, so I'm gonna try some of these features. So I'm interested in the battery test. So that's live data. This allows you to check safety systems on your car like braking and lighting. This also allows you to clear your check engine light and DTC codes. You can also view live data streams to pinpoint the cause of engine problems. This is a full tool that also checks your transmission system, ABS, and your supplemental restraint systems like airbags. And these are fault codes with the transmission. So again, fluid pressure switch, fluid pressure sensor, fluid pressure, so lots of fluid pressure things. And again, these aren't necessarily codes that it has, it's codes that it kind of is defining codes. So we'll check a couple of these and then let's graph. So again, you've got like voltage and throttle position. There you go. So as you can imagine, it's very helpful to troubleshoot any problems your car has. If a tool like this can just save you one trip to the mechanic, it's probably worth it. So if you're interested in a tool like this, I'll leave a link in the video description below. All right, we are going to install, this is the inverter board for the large drive unit. These are also cables, so we're gonna get to installing this one today. So I've gotten into an inverter probably a half dozen times, so we're gonna go ahead and time this one, see how quick we can do it. So we're gonna take off plate, the plug cover, cables here, this whole housing. Then we're gonna swap out the inverter board and then put it all back. I'm gonna say half hour or less, hopefully 20 minutes. So we'll go ahead and start the timer, so go. There we go. Jeez Louise. So I almost forgot, you have to take off the 2 bolts for the cables. You don't actually have to take out the cables, but you have to take out those bolts because they're bolted here. Basically, next is this board. This is the inverter board we have to take out. So again, there's lots of connectors, 1, 2, 3, 4, 5, 6, 7 connectors. Then we have to take out these screws. We leave this one in because that keeps the back on, and we'll swap out the board. Another thing that's nice is all the connectors are different, so you don't really have to worry about mixing them up. And I think this is the last one. All right, so this is the inverter board. This still has value. I burnt through 2 of these on my first build. So again, lots of people are looking for these depending on what kind of build they're doing. We're gonna go ahead and swap this one out with the AEM board. Just make sure you repopulate all the connectors. I always like to do these by hand just because I don't trust. Much better. So this little plug was kind of getting stuck. Okay, time. We got 26 minutes. Basically open that guy up, swap out the board, put everything back with torque specs. And that. Okay, let me show you what we got. These two are for the motor. So I've been looking at how we're gonna mount the motor, and I believe we're gonna need to mount it in reverse. And so that's what this is. It's a reverse pump, so that when we actually drive it in the reverse way, this will still apply the oil lubricant to the gears as needed. And this one I'm really excited about. There we go. Oh my goodness, so heavy. What this is a limited slip differential. So I'm gonna show you a video here, but the Tesla has an open differential. I'm showing you a quick race we did with some fellow EVs that also had Tesla drive units. And I wanted to show you my car. As I'm leaving the line, you'll see I've got 2 tire marks, which means both tires are kind of putting down good power. I also wanted to show you this red car. It also has a Tesla large drive unit, and you'll notice it is doing a one-wheel burnout for most of the race. So in theory, what that means is if one wheel starts to lose traction, essentially that's going to be the easiest wheel to spin and the other wheel won't provide any power. With that being said, with my blue car, I do not have this, and it puts down power with both wheels just fine. If I peel out, it leaves 2 marks, not 1. But I will tell you, I have seen other cars that will do a one-wheel burnout if you don't have something like this. So I talked to the customer about it, and we're going to go ahead and do this, especially since we're probably going to need to get into it to install this anyway. Okay, one of the first things we need to do when we're splitting this to access the differential, there's 3 bolts that hold on the bus bars that kind of join the inverter half to the motor. So we got to get those off, and then we can start removing some of the bolts. So no matter how much you've drained of the gear oil or transmission fluid, there's always going to be more that comes out. So now we're going to these main bolts here, as well as the carrier bolts back there. All right, I believe I've got all the hardware off in order to separate. The challenge is there are not a ton of good surfaces to kind of pry against. Again, you don't want to damage any sealing surfaces, so we'll probably go on the outside of some of the bolt holes. I think the backside of this is also a good place. We'll get to prying this apart. All right, we've got it all open now. So I don't know if this was the best way to do it, but you do have to separate the differential from the bearing there. And I just chose to put a couple bolts or a couple nuts on there and pry it apart that way. Came out okay, so I think that worked all right. Other than that, I'm just cleaning up kind of the edges so I can put a new gasket on. But now we'll go ahead and take the differential out. We are also going to be taking out the pump. We're going to do a reverse pump. So that means this one's got to come off too. So let's get to it. So that one slides out easy. When it's on this guy though, it's so cantilevered, it's hard to get it in straight. And I guess I gotta remember that this goes in between. So when I put them on, there we go. Just had to tap it from this other side. So we need to take the ring gear off and put it on the new differential. Jeez Louise. My impact sucks. Stay on target, come on. Oh, there we go. There we go. All right. Out with the old, in with the new. So this is the Quaife limited slip differential. I do have to say that, man, like this hardware and the ring gear, everything is just massive to handle all the torque. But we'll get this cleaned up and we'll get the new differential put on and get things put back together. All right, we're really not gonna tighten it with this. We're just gonna snug everything up. Now it's time to torque things in place. All right, at long last, we've got all the bolts tightened. Man, it's just really challenging to hold on to this thing to get enough torque to tighten all those bolts. But we've got them all tight, so we'll go ahead and fit the bearing on and put it back in. Now that we've got the limited slip in place, we need to do one more thing before we start putting things back together, and that is this pump. For this particular application, we are going to be running this one in reverse, and so we need a reverse pump. So basically we just need to take off a few bolts, slide that out. We keep the same internal, but the outside gets swapped. All right, so we took this whole oil system off, and really it's kind of challenging to get this off because it's got a clamp on here and it's hard to kind of get that off while everything's in place. So just 3 bolts here, we'll take this one off. This is what we're changing. So basically we're keeping this piece here, we're keeping this piece here, but the outer piece we're replacing. All right, so this is what we're looking at. And basically the new one just has kind of these vanes reversed so that when this gear spins, it'll pump things the other direction. And we've got all the pieces flipped over, so we can put this one back in. I also took out these spring pins. We'll transfer them to the new one. Okay, we are ready to put this one back. Can't forget this one with the clip. All right, one other thing to notice, I'll say how it's laying here is fairly typical, meaning in a Tesla, this is how it is. The port at which it recycles the oil is kind of down a little bit to the right. So the reason why I bring that up is I think I'm gonna have to tilt the motor up, maybe 30 degrees. That fill point is still gonna be very much at the bottom of where all the fluid will collect, so we will be just fine. All right, the last thing we need to do is put this one in, and we've got bearings that need to go on both sides. So there's this bearing, and then there's also the carrier bearing. So both those bearings need to go on both sides. I think what we'll do is, we'll put the bearings on. Always remember that this plate's got to go in the middle, put them on, and then we'll see if we can assemble. It's usually one of the more challenging things, but I think if we can get those long carrier bolts through there, we can kind of use the nuts to kind of squeeze things together. Okay, we got it in. That's a little challenging just because it's got so much weight. So kind of put both bearings on. I was a little leery of using the press. When I say my press, this is the lift. Just using all that weight, if it wasn't quite even, it's kind of hard to see. So I just opted for the rubber mallet, nice soft blows to kind of make sure everything sat just right and kind of hitting only the inner race. So got both the bearings on, and then to push it on, got some blocks, even got a wedge. You could kind of adjust the height. And man, yeah, if you get it just right, slides right in. So now I can put the nuts on the back and everything's ready. So I think just continue cleaning this up and add some gasket maker, and then we can put it back together. All right, I'm just going to snug these up. All right, you can see the gasket material that's sticking out here. So I've not torqued everything down. It says to kind of just snug it up. So we will wait for this to set up and then torque everything to spec. There we go. All right, here we are. It's been about 36 hours. We're gonna go ahead and we're gonna tighten all these bolts to spec. So no Tesla motor upgrade would be complete without the Revolt Systems Coolant Bypass Kit. This is a billet aluminum, and this is a plate that blocks off one of the most prone areas to failure for the electric motor. And this is amazing. They've got a spot for nerds. All right, so I'm going to talk a little bit about why this is necessary. The guy I usually source all my motors from is EV Parts Guy. And the number one thing that they look for as soon as they pull the motor is they'll pull this off and see if it's leaking. So this is like the number one spot that causes issues with motors. So you can do this not only for kind of aftermarket purposes like we're doing it, but even if you have a Tesla right now, a Model S or Model X, that's after warranty, this would be a good investment. It's a couple $100 and it'll save you a whole new motor. So this is kind of, I'll call it the inlet. This is the encoder sensor. So again, gonna take that one off and it gets repopulated. Both of these get repopulated, but gonna take those off, take this whole plate off, as well as this pipe. So it never fails. As much as you drain this, there'll always be more that comes out. Without fail. And again, because this has got some of that gasket material, it'll stick just a little bit. Got a little screwdriver or pry bar, that'll work just fine. Path splits. I don't know if you can tell that, but basically when coolant goes in, I'll say the majority goes down, but some of it goes through the tube. And I'll play a video here from Weber Auto that kind of shows you where the cooling channels are.
This is where the coolant would come into this drive unit. Now, as it comes into the drive unit, it goes two ways. One way is that it goes up and then all the way down the middle of this hollow shaft right here. And this hollow shaft with a seal sticks down inside of this rotor. So it runs coolant down through the center of the rotor where it's blocked off at the bottom, and then it has to come back up around the outside of this tube where it goes through this seal, and then it goes up and out the top right here.
You might be wondering, blocking that off, is that gonna not cool something that should be cooled? Kind of. So there's kind of, I'll call it three main components that temperature is pretty sensitive. You've got the stator, the rotor, and the inverter. So there are two paths for the coolant here. One goes to the rotor and then to around the transmission. And the other path goes to the stator and the inverter. So for this drive unit, when you drive hard, again, like Teslas around the track, things like that, the side that heats up first is the inverter and stator side. So that fluid channel is the one that is most critical. There's a lot of people have done this block off plate and haven't had any problems with overheating of the other components. But essentially down here is the main part that we care about. This cools the whole stator assembly. This also cools the inverter and the boards that are in there. So again, this is the most important part. So this one was starting to go bad. You can kind of see where it's starting to go bad. And again, if that goes bad, you're starting to fill up your stator with fluid, and then also it'll leak into your inverter. So your whole motor will be toast. So that's why something like this is so important. All right, I've got some of my gasket maker. Just gonna put a bead around here before we put the new plate on. Like when we join the two halves, we just kind of do this, I'll call it snug, and then we'll torque them all to spec once the gasket material is set up. You can kind of see the gasket material squeezing out, so again, that's a good sign. But in the meantime, we can put these guys back on. And last but not least, this one will cap off right over here. We'll give this 24 hours to set up, and then we'll tighten everything to torque specs. All right, here we are the next day. Everything's set up, so we'll go ahead and torque things to spec. That's how easy it is to install this and keep your motor safe. That is from Revolt Systems, and if you're interested in something like this, I'll leave a link in the video description below. All right, just real quick, I'll go over some of the tools I used. Got your standard sockets, rubber mallet. I used just a little scraper to get some of the gasket off. Impact driver, I need a much better one. A little torque wrench, screwdrivers, we got a big torque wrench and a vise, which I need to mount somewhere. But yeah, not a ton of tools that you need for this job. I do have a hoist to lift things up. I have done this before where you just kind of roll this thing around. It's pretty heavy, but having something to lift that up would be nice. All right, we were able to swap out the inverter board. We got a brand new differential, even put in a reverse pump. Got all these nice upgrades for the Tesla motor. Thanks for tuning in. See you next time. All right, I've gotten into Thanks for tuning in. See you next time. Oh.